December 12, 1940. High Command of the Wehrmacht, Zossen, Germany. Colonel Walter Wemont, serving as Deputy Chief of Operations, addressed the assembled German General Staff with the latest intelligence evaluation regarding the industrial capabilities of the United States. His report, built upon extensive data collection and surveillance, methodically dismissed the notion that American industry could pose any significant military threat. According to the assessment, American factories were optimized for civilian production rather than wartime needs. Workers lacked prior experience in armaments manufacturing, and contingency strategies to employ women in war production were interpreted as a sign of systemic weakness rather than potential strength. Detailed reports indicated that current American output was minimal, roughly 300 aircraft per month, fewer than 20 tanks, and negligible quantities of military vehicles. At that time, the United States Army ranked 17th in global size, trailing even Romania. These conclusions informed German strategic planning, which anticipated a drawn-out conflict without immediate concern from American industrial power. However, this assessment overlooked a profound transformation quietly beginning thousands of kilometers away. American industry was on the brink of an unprecedented expansion that would soon overwhelm German forces with a relentless surge of war material. The women who were discounted as peripheral would become the backbone of production, manufacturing more equipment in a single month than Germany could produce in a quarter. Factories once devoted solely to consumer goods would be repurposed with extraordinary speed, marking the start of one of history's most extensive industrial mobilizations. Within 2 years, German intelligence would watch with mounting unease as American output surged far beyond all initial projections. The mobilization of millions of American workers, particularly women, would become a strategic advantage of unmatched significance, proving more destructive to the Nazi war effort than any tactical defeat on the battlefield. German planners in 1940 were working from accurate data. They knew American aircraft output averaged 300 units monthly, and that tank production remained largely experimental. Military vehicle production was almost non-existent, and the U.S. Army comprised roughly 269,000 troops, poorly equipped by European standards. These observations were factually correct, and German analysts documented them meticulously in strategic reports stored today in the Bundesarchiv. Wehrmacht economists calculated that converting civilian factories to military production would require 3 to 5 years based on experience in Germany. They noted structural limitations. American factories operated single 8-hour shifts, weekends were strictly observed, and labor unions resisted abrupt changes in productivity. Recruiting women for industrial work was viewed as a sign of desperation, not capability. These assessments were grounded in prior European experience. Germany's own secret rearmament starting in 1933 required 6 years to reach substantial output. France's attempted mobilization in 1939 to 1940 had failed disastrously, and British production after 18 months of war remained constrained. Yet, German analysts assessed American potential through a European lens. They could not imagine a system capable of training millions of inexperienced workers in a matter of weeks, constructing fully operational factories on empty sites within months, or inspiring a workforce through patriotic dedication. Most crucially, the idea that American women could master precision manufacturing at speeds surpassing seasoned German workers was inconceivable. The turning point for U.S. industrial mobilization occurred in May 1940. As France fell and Britain stood alone against Germany, American industrial planners accelerated preparations for war. President Franklin D. Roosevelt's ambitious goal of producing 50,000 aircraft annually initiated a sweeping transformation in production practices. William Knudsen, then president of General Motors, was appointed head of the Office of Production Management. Under his direction, American manufacturing underwent radical change. Major competitors including Ford, Chrysler, Packard, and Studebaker shared proprietary knowledge, production techniques, and specialized machinery, an unprecedented level of industrial cooperation. In contrast, such collaboration in Germany was virtually impossible due to intense corporate rivalries. This rapid reorganization marked the beginning of an industrial era that would decisively influence the outcome of the war. What appeared to German planners a slow, fragmented, and unprepared industry would, within months, transform into a production juggernaut capable of eclipsing all prior expectations and redefining the balance of power on a global scale. Preparations to convert the American automotive industry to wartime production began well before the nation was drawn into World War II. 18 months prior to the attack on Pearl Harbor, leaders in Detroit were already charting strategies that would redefine modern warfare. In June 1940, executives initiated unprecedented collaboration across competing companies. They standardized components, shared specialized machinery, and rotated workers through multiple skills to ensure flexibility. Henry Ford, who had initially resisted entering the aircraft engine sector, changed course and committed his company to mastering unfamiliar technologies, acknowledging openly that they would have to learn what they did not yet know. At the same time, a societal shift was quietly taking shape throughout the United States. Women independently sought out education and training in fields previously considered male domains. Welding, blueprint interpretation, and precision measurement courses saw surges in female enrollment, entirely driven by personal initiative rather than government programs or official recruitment campaigns. By September 1940, thousands of women were actively equipping themselves for industrial roles. Institutions like the Bullard Havens Technical School in Connecticut, which had historically excluded women, suddenly faced applications numbering in the hundreds. Comparable trends emerged nationwide, signaling that women were anticipating the country's workforce demands ahead of formal acknowledgement. The attack on December 7, 1941, abruptly accelerated these transformations. The Japanese strike on Pearl Harbor triggered a scale of industrial mobilization beyond any prior projection. Within just 2 days, employment centers across the country were inundated with volunteers, the majority of whom were women. The Boeing facility in Seattle illustrates the pace of change. On the eve of the attack, the plant employed around 8,000 people, predominantly men. By the start of 1942, the workforce had doubled, with women filling most of the newly created positions. This trend continued rapidly. By June 1943, Boeing's employment reached 45,000, with women performing the majority of assembly line operations. Meanwhile, German intelligence, monitoring U.S. mobilization via neutral observers, initially dismissed American production goals as exaggerations. In early reports, the United States outlined plans to manufacture 60,000 aircraft in 1942 and 125,000 in 1943. German analysts, whose own nation produced only 12,000 planes per year, regarded these figures as implausible propaganda. What they failed to grasp was the transformative approach to industrial engineering emerging in the United States. Building on Frederick Taylor's principles of scientific management and refined by Charles Sorensen at Ford, American factories deconstructed complex manufacturing processes into highly specific, repeatable tasks. Workers were no longer trained to build entire assemblies. Instead, each individual mastered a narrow function, drilling precise holes, installing designated rivets, or connecting specific wiring. When hundreds of specialists executed these tasks in unison, entire aircraft could be completed with unprecedented speed. By March 1942, production rates at American plants were already surpassing the expectations of foreign observers. The Willow Run plant exemplifies this revolution. Barely a year prior, the site was farmland. Within months, it had transformed into an enormous industrial complex covering 3.5 million square feet. Designed to accommodate 42,000 workers building B-24 bombers, it would become the world's largest factory under a single roof. German intelligence continued to reject U.S. claims. Experts calculated that constructing a 4-engine bomber required at least 4,000 skilled man-hours, making the American assertion of producing bombers at intervals of just over an hour seem impossible. Yet Willow Run's innovative assembly line methods defied these assumptions. The facility's workflow resembled a massive moving assembly line, with aircraft progressing through 1,600 distinct stations. Women performed the majority of operations, handling drilling, riveting, welding, and electrical installation with pneumatic tools that German factories lacked. Entire fuselage sections that traditionally required hours to assemble were completed in under an hour. Workers like Rose Wilman Monroe became emblematic of this effort, operating pneumatic riveters to complete sections in roughly 45 minutes, a task that would have taken German workers 8 hours. These contributions would later inspire the iconic image of Rosie the Riveter, symbolizing women's central role in America's wartime industrial surge. By combining large-scale workforce mobilization with advanced industrial engineering and the proactive engagement of women, the United States achieved production capabilities that astonished the world and reshaped societal expectations, demonstrating that coordinated planning, innovation, and human initiative could dramatically accelerate industrial output in times of crisis. By the spring of 1944, Willow Run had reached an extraordinary pace in aircraft production, rolling out a B-24 bomber roughly every hour. Over the course of the war, the facility would ultimately produce 8,685 of these heavy bombers. The involvement of American women in the industrial effort directly contradicted Nazi ideology, which insisted that women were suited only for household duties. For German leadership, the idea of women contributing to weapons manufacturing was not merely impractical, it was considered a sign of racial and social decay. Yet, by the middle of 1942, American women were demonstrating remarkable proficiency in industrial roles. At the Douglas Aircraft Plant in Long Beach, California, women made up 40% of the workforce by 1943. Their systematic training programs and improved work methods allowed them to surpass the efficiency of pre-war male laborers. Similarly, the Richmond shipyards in California employed approximately 90,000 workers at peak output, with women constituting 27% of the overall workforce and 41% of the welders. These teams built Liberty ships in record times, averaging just 45 days per vessel, with the SS Robert E. Peary famously completed in only 4 days, 15 hours, and 29 minutes in November 1942. By comparison, German shipyards required nearly a year to construct equivalent ships. Women also excelled in precision tasks previously considered unsuitable for female labor. At the Sperry Gyroscope Company, female workers assembled bomb sights with tolerances as fine as 10,000ths of an inch. Their careful attention and steady hands often exceeded the standards achieved by experienced male craftsmen. Among these women was Norma Jean Doherty, who would later gain fame as Marilyn Monroe. From late 1944, she worked at the Radioplane Munitions Factory, inspecting parachutes and assembling target drones. Her experience reflected the broader trend of women entering complex industrial roles without prior training, quickly mastering highly technical work. By August 1942, the United States had reached production levels that made German defeat a mathematical certainty. Aircraft output neared 4,000 per month, roughly equivalent to Germany's production over an entire quarter. Similarly, American military truck production surpassed Germany's monthly output on a weekly basis. The U.S. Strategic Bombing Survey later documented the scale of this disparity in detail. In 1942, the United States manufactured 47,836 aircraft, compared with Germany's 15,490. By 1944, American production surged to 96,318 aircraft, while Germany produced 40,593. Tank production revealed similar imbalances. At the Detroit Arsenal, Sherman tank output approached 900 units per month by December 1942. German tank production, in contrast, averaged around 500 per month across all models. This meant that the United States could replenish battlefield losses faster than German forces could inflict them. Field Marshal Erwin Rommel experienced the consequences of this material imbalance firsthand during the North African campaign, repeatedly reporting to Berlin that American logistical superiority made German resistance increasingly futile. For every tank destroyed, multiple replacements appeared, while American supply lines seemed inexhaustible compared to the strictly rationed German resources. Boeing's production of the B-17 Flying Fortress exemplified American industrial strength. By mid-1943, Boeing's Seattle plant employed 45,000 workers, with large numbers of women joining after recruitment campaigns that began in June. The plant produced approximately 16 B-17 seconds each day. When combined with output from Douglas and Lockheed, bomber production exceeded the rate at which crews could be trained. By early 1943, American bomber formations were expanding month by month, outpacing the German Luftwaffe's ability to counter them. German fighter pilots quickly recognized the futility of their missions. Adolf Galland, the Luftwaffe's fighter command leader, later admitted that by 1943, the air campaign was effectively lost. American industrial production had rendered tactical German successes irrelevant. The Liberty ship program further illustrated American manufacturing capacity. The Maritime Commission had pledged to construct ships faster than German U-boats could sink them, a seemingly impossible task. Admiral Carl Junit initially calculated that replacing lost vessels would require 200 ships annually, a figure beyond global shipbuilding capacity. Yet American shipyards ultimately launched 2,751 Liberty ships during the war. Innovations introduced by the Kaiser shipyards, including prefabrication and assembly line techniques, allowed ships to be built in sections and rapidly assembled. Women welders took on roles traditionally performed by riveters, dramatically shortening construction timelines. American wartime production, driven in large part by women entering the industrial workforce and by revolutionary methods in manufacturing, created an overwhelming material advantage. Aircraft, tanks, trucks, and ships flowed from factories at speeds Germany could not match, decisively shaping the outcome of the war. By the spring of 1943, the United States had achieved a remarkable feat in industrial mobilization. Components for war material were manufactured on a massive scale and then rapidly assembled into fully operational equipment. American shipyards, at the height of their efficiency, were launching 3 Liberty ships each day, while enemy submarines, the U-boat fleet, were sinking roughly 1 ship every 3 days. Faced with this overwhelming output, Admiral Donitz decided to withdraw German submarines from the Atlantic, acknowledging that U.S. industrial capacity had effectively neutralized the U-boat maritime campaign. Meanwhile, the Douglas Aircraft Factory in Santa Monica employed approximately 44,000 workers across 3 shifts by 1943. This workforce produced 360 C-47 transport aircraft every month, surpassing Germany's entire fleet of transport planes. Women not only performed assembly tasks but also contributed to process improvements, devising workflow optimizations that enhanced both production speed and quality. As a result, American aircraft manufacturing achieved a level of mass production that matched or exceeded traditional handcrafted standards. Every part underwent strict testing and inspection, and rejection rates remained lower than German facilities, even under accelerated production schedules. The Lockheed factory exemplified the U.S. capability to mass-produce advanced aircraft. The P-38 Lightning, one of the era's most sophisticated fighters, was assembled largely by newly trained women workers who produced aircraft meeting German standards of quality. On the armored front, the Detroit Arsenal in Warren, Michigan, began operations in 1941 on 113 acres. By late 1942, its production rate approached 900 M4 Sherman tanks per month, outstripping Germany's entire monthly tank output. Women operated large presses to form armor plating, worked precision lathes, machined components, and maneuvered 30-ton turrets with overhead cranes. They mastered welding and assembly of armor sections, performed quality control checks, and ensured that tanks were combat-ready. In contrast, German tank production faced intrinsic limitations. The Tiger tank, though technically superior on a per-unit basis, required extensive hand-fitting and assembly. Germany produced only 1,354 Tigers during the entire war, whereas the US manufactured 49,234 Shermans. The overwhelming numerical advantage of American tanks outweighed the qualitative superiority of German models. Captured Shermans demonstrated mechanical reliability and fully interchangeable parts, whereas German tanks depended on model-specific components, complicating maintenance and repairs. American mass production principles extended to small arms as well. At the Rock Island Arsenal, production expanded from 500 rifles per month in 1940 to 5,000 Montgarand rifles daily by 1943. Women composed more than half of the workforce, operating multiple milling machines simultaneously to manufacture components with precision exceeding military specifications and minimal rejection rates. This mass production allowed American soldiers to carry semi-automatic rifles, providing a significant firepower advantage over German infantry armed with bolt-action rifles, largely unchanged since World War I. The disparity in firepower was magnified across entire armies. Ammunition production followed a similar trajectory. At the Lake City facility, predominantly staffed by women, output reached 60 million cartridges weekly by 1943, far surpassing Germany's monthly capacity. Resource production highlighted further advantages. Aluminum, critical for aircraft manufacturing, was produced in vastly greater quantities in the United States than in Germany. In 1942, Germany produced only 250,000 tons, stretching its resources thin, whereas the United States generated 920,000 tons with potential for further expansion. Alcoa's Tennessee plants, powered by hydroelectric dams built by the Tennessee Valley Authority, employed women to operate massive electric furnaces, producing enough aluminum daily to supply multiple aircraft. German shortages in aluminum forced the substitution of heavier materials like steel and wood, reducing aircraft performance. By contrast, American planes extensively utilized aluminum, resulting in superior speed, range, and payload capacity, directly translating into combat effectiveness. Through the combined efforts of a diverse workforce, advanced industrial organization, and an abundance of resources, the United States not only scaled production to unprecedented levels but also maintained strict quality control, creating weapons systems that were both highly effective and maintainable. This industrial advantage played a decisive role in overwhelming Axis forces on multiple fronts. American industry during World War II reached a level of precision and reliability in mass production that traditional craftsmanship could not match, largely thanks to the implementation of statistical quality control pioneered by Walter Shewhart and W. Edwards Deming. Processes that had previously depended on the skill of individual artisans became standardized and replicable. At Pratt & Whitney's plant in Connecticut, women inspectors upheld quality standards surpassing those required in Germany, ensuring every part could be replaced interchangeably without issue through repeated inspections at multiple stages of production. Packard Motor Company, licensed to manufacture Rolls-Royce Merlin engines, not only replicated British designs but enhanced them through meticulous production engineering. The engines produced in the United States exceeded original specifications while being manufactured at speeds never before seen. This remarkable output was supported by a highly organized transportation infrastructure which delivered raw materials with near-clockwork reliability. Women were integral to this system, from managing railroad operations to planning complex logistics. Their numbers on the railroad soared from 4,000 in 1940 to over 100,000 by 1944. They handled switchyard operations, track maintenance, and the coordination of vast quantities of materials, enabling rail networks like the Pennsylvania Railroad to move more freight in a single day than Germany could transport across its entire system. This logistical efficiency allowed American factories to continue production without interruption, in contrast to German plants that frequently stalled due to supply shortages despite shorter transport distances. Unlike Germany, which by 1943 dedicated 70% of its industrial output to military production, the United States maintained civilian manufacturing alongside its war effort. Even while producing enormous quantities of military equipment, American workers continued to supply consumer goods. Military expenditure never exceeded 40% of national production, yet output still outpaced German efforts. The key factor was systematic productivity. American factories applied time and motion studies, continuous production improvements, and worker-driven innovations to maximize efficiency. Women operating automated machinery often outperformed multiple skilled craftsmen using conventional methods. When scaled across millions of workers and production lines, these efficiency gains proved decisive. In the submarine sector, women made up 40% of the workforce at Electric Boat Shipyard in Connecticut by 1943. They built fleet submarines in just 180 days, while German U-boats, despite simpler designs, required nearly 300 days. The ability of women welders and assemblers to work in confined, challenging spaces accelerated construction considerably. By 1943, American submarine output not only surpassed Germany's but also produced larger, better-equipped vessels, enabling devastating effects on Japanese shipping. Similarly, radar and electronics manufacturing demonstrated the advantages of American industrial organization. At the Raytheon factories, women assembled sophisticated radar units in quantities Germany could not match. By 1943, American radar production had reached thousands of units monthly, equipping almost every ship, aircraft, and key ground installation, whereas German forces possessed only a limited number of systems in entire sectors. Communication systems also benefited from female labor. Western Electric, with a predominantly female workforce, produced 100,000 military radios per month by 1944, giving U.S. forces superior communications capabilities at every level, from squad radios to strategic networks. At the Holston Ordnance Works, roughly 40,000 employees, 70% of them women, manufactured RDX explosives. In 1943 alone, production exceeded Germany's total wartime output. Safety measures in these facilities were rigorous, and women consistently achieved exceptional safety records, handling highly dangerous materials that German doctrine considered too risky for female workers. Systematic training and adherence to safety protocols allowed American plants to maintain both high output and low accident rates, reflecting a level of industrial discipline unmatched by Germany. Through innovation, organization, and the strategic mobilization of women in both production and logistics, the United States achieved an industrial superiority that translated directly into wartime advantage. The combination of advanced manufacturing techniques, logistical precision, and the utilization of an expanded workforce allowed American industry to produce more, faster, and safer than any adversary, shaping the outcome of the war through sheer industrial power. During World War II, the contrast in artillery usage between American and German forces was stark. American units could fire nearly limitless barrages, whereas German batteries often held back, conserving shells due to production limitations. This disparity stemmed from the scale and organization of American munitions factories, many of which employed women who produced explosives in such quantities that conservation of ammunition became unnecessary. The United States' advantage extended beyond weaponry into medical innovations. Penicillin production is a prime example. In 1942, production levels were sufficient to treat only about 100 patients. Within 2 years, output had expanded dramatically to allow for 100,000 treatments per month. Consequently, while German soldiers frequently succumbed to infections from battlefield injuries, American medics were able to treat such wounds with remarkable consistency and success. Alongside antibiotics, the production of surgical instruments grew exponentially between 1941 and 1944. Women working in facilities like Becton Dickinson manufactured these tools at volumes that ensured American wounded received superior care compared to their German counterparts. The Red Cross organized blood plasma production, relying heavily on female labor, which saved countless lives and contributed to an unprecedented survival rate among American soldiers, in sharp contrast to German casualties, which were exacerbated by shortages in medical supplies. Industrial capacity also allowed America to respond swiftly to resource disruptions. When Japan seized control of rubber-producing regions in Southeast Asia, the United States initiated large-scale synthetic rubber production from scratch. By 1944, American plants largely staffed by women were producing 737,000 tons annually, vastly outpacing Germany's peak production of 110,000 to 120,000 tons. Chemical engineers developed processes that improved synthetic rubber for specialized uses, and innovations were quickly shared across industries, creating a multiplying effect. The result was a vast surplus of tires and other essential materials, allowing American vehicles to operate reliably, while German vehicles frequently failed due to tire shortages and rationing. The Quartermaster Corps later documented these conditions, labeling the American military as the best equipped in history. Textile production reflected a similar pattern. Women in textile mills manufactured 100 million uniforms, 500 million pairs of socks, and 60 million pairs of boots. Parachute facilities relied on female workers for precision sewing, where each parachute required thousands of meticulous stitches, and rejection rates were kept exceptionally low. German soldiers often faced Russian winters in summer clothing, whereas American troops received uniforms suited to every climate. The origin of this advantage lay in the organized, large-scale efforts of women in textile plants who produced functional, climate-appropriate equipment on a massive scale. Technological production also benefited from this workforce. At Motorola, 14,000 employees, most of them women, manufactured the SCR-300, the first portable FM military radio, at a rate of 50,000 units per month. By 1944, every American infantry squad possessed a radio, while German companies were able to supply only one radio for multiple units. This communication superiority provided critical tactical advantages, partially offsetting differences in battlefield experience. Similarly, Bosch and Lum employed around 9,000 workers, mostly women, to produce binoculars, rangefinders, and bomb sights, outpacing Germany's entire optical industry, including Zeiss and Leica combined. American forces had abundant optical equipment, whereas German troops often prized single items. Vehicle reliability, another key factor in operational readiness, owed much to women manufacturing spare parts. Factories like Delco Remy produced millions of spark plugs, batteries, and generators, enabling American vehicles to remain operational while German forces frequently had to dismantle existing vehicles to replace parts. Preventive maintenance became routine for American units, multiplying combat readiness and mobility. Fuel production followed a similar trajectory. Women at Texas refineries produced high-octane aviation fuel, giving American aircraft superior performance. German pilots often flew with lower-quality synthetic fuels when available, limiting both training and combat effectiveness. This disparity in fuel availability meant that American pilots could train freely and operate without constraint, while German training remained tightly restricted. Captured German documents reveal the psychological impact of encountering this overwhelming material superiority. Letters from soldiers describe the morale-crushing effect of seeing American forces consistently well supplied. German propaganda proved ineffective when confronted with the reality of American abundance, eroding soldiers' confidence and challenging ideological narratives. Every captured position highlighted the tangible consequences of American industrial and logistical power. In summary, the United States' wartime advantages stemmed not only from strategic decisions or battlefield tactics, but from the enormous organized contributions of women across munitions, medical, textile, technological, and chemical industries. Their work ensured that American forces operated with abundant, reliable equipment, medical care, and supplies, while German troops frequently faced shortages, mechanical failures, and inadequate resources, fundamentally shaping the outcomes on multiple fronts. Operation Overlord highlighted the decisive role of industrial capacity in modern warfare. The Allied invasion force consisted of roughly 5,000 ships and over 11,000 aircraft, nearly all manufactured within the preceding year and a half, with women comprising the majority of the workforce. German defenders faced overwhelming material odds, rendering their resistance almost mathematically impossible. For every German shell, 20 American rounds were ready. For each German aircraft, 50 American planes took to the skies. Individual bravery, while commendable, could not offset such disproportionate firepower. American forces consumed approximately 1,000 tons of supplies daily, compared with the mere 30 tons allocated to German units. This disparity stemmed from a workforce, especially women, capable of sustaining high-output production, allowing prolonged operations without interruption. Meanwhile, the United States maintained parallel campaigns in the Pacific with equivalent material advantages. Admiral Yamamoto's assessment, made 6 months prior, significantly underestimated American industrial and logistical strength. The construction of Essex-class aircraft carriers illustrates the scale of American production. Each 27,000-ton carrier, built in only 20 months, contrasted sharply with Japan's 4-year construction timeline for similar vessels. By war's end, the United States had produced 24 carriers. Japan managed just 6. Workers at Newport News applied assembly line techniques to ships that elsewhere required artisanal craftsmanship, enabling rapid, systematic mass production. By 1944, American bomber output had reached levels sufficient to conduct raids involving thousands of aircraft simultaneously. The 8th Air Force alone fielded more four-engine bombers than Germany produced throughout the entire war. Companies such as Boeing, Douglas, Consolidated, and North American employed tens of thousands of women who collectively produced over 96,000 planes in that year. Germany, despite technological improvements, manufactured just over 40,000 aircraft. American women, therefore, were pivotal in generating air superiority, a numerical advantage Germany consistently misjudged due to entrenched assumptions that women could not be skilled industrial workers. These social biases led German analysts to systematically undervalue production reports, assuming figures far exceeded human capacity. In contrast, field commanders observed the reality firsthand. By late 1944, Germany suffered from critical fuel shortages immobilizing tanks and vehicles, while American forces operated continuously. Logistics played a central role in operational capability. American soldiers received 67 pounds of supplies per day, compared with only 4 pounds for their German counterparts. Supply lines were meticulously managed, moving millions of tons of material monthly with precision across vast distances. Replacement systems were robust, equipment losses were immediately replenished, and personnel replacements flowed steadily into units. German formations, once weakened, rarely recovered to full strength, whereas American divisions could rebuild quickly after combat. The Battle of the Bulge underscored this advantage. Despite the surprise German offensive, American troops, fully equipped for winter operations, outmatched attackers who had months to prepare and had to improvise with inadequate gear. Artillery ammunition was plentiful, allowing concentrated fire, whereas German units conserved rounds due to production limitations at munitions factories primarily staffed by women. Communications and medical logistics further demonstrated the impact of industrial output. American units had multiple radios, mass-produced by women, ensuring effective coordination. German forces, by contrast, often shared single radios. Medical supplies, including plasma, medications, and surgical equipment, were widely available, allowing wounded soldiers to survive at unprecedented rates. Motorization transformed mobility. The United States produced 800,000 2.5-ton trucks, while German forces relied increasingly on horse transport. Transport aircraft, such as the 10,000 C-47 seconds constructed at Douglas, enabled supply to isolated units indefinitely. Surrounded American troops could be resupplied. Encircled German forces faced inevitable surrender. Engineering and technical support were amplified by mass production. Bulldozers and excavators, built primarily by women, allowed rapid construction of fortifications and infrastructure, whereas German engineers relied on hand tools. Signals intelligence benefited from machines manufactured at NCR and IBM, dramatically enhancing analytical capabilities. Thousands of mechanical computers multiplied human effort, enabling superior operational planning and execution. In sum, the outcome of Allied operations in 1944 was as much a product of organized industrial power and the systematic integration of female labor as it was of battlefield tactics. Production capacity, logistical precision, and the ability to maintain and replace men and material continuously created an environment where sustained operations could succeed, while German forces, constrained by limited output and outdated assumptions about workforce capabilities, were progressively degraded. The war's arithmetic was overwhelmingly defined by the industrial mobilization of women, whose labor produced the planes, ships, vehicles, weapons, and supplies that decisively tipped the scales. Radar systems became widely deployed thanks to mass production at factories like Raytheon and Western Electric, eliminating the element of tactical surprise in combat. American troops benefited from a steady flow of comfort items, cigarettes, sweets, magazines that supported morale, while German soldiers often went months without any supplies. USX manufacturing simultaneously equipped the armed forces and met civilian needs, highlighting the industrial balance that supported total war. Allied leaders, including Soviet and British officials, repeatedly acknowledged that American production played a decisive role. At the Tehran Conference, Stalin explicitly praised the output of US industry, while Churchill from the outset recognized that American manufacturing capacity would be a turning point. Vehicles like Studebaker trucks enabled Soviet troop movements, Liberty ships kept Britain supplied, and countless aircraft strengthened the Allied air campaigns, all largely constructed by American women whose work proved indispensable to the war effort. The scale of American production during World War II remains astonishing. By the war's end, the United States had delivered roughly 296,000 airplanes, 193,000 artillery pieces, 86,000 tanks, 2.66 million machine guns, over 6 million tons of bombs, 434 million tons. Women made up significant proportions of the workforce, up to 65% in aircraft factories, 40% in some shipyards, and 55% in munitions plants. Their output consistently surpassed all expectations, demonstrating industrial skill and efficiency at an unprecedented scale. Post-war surveys and interviews conducted by the United States Strategic Bombing Survey revealed that German commanders recognized the decisive impact of American production. Field Marshal Kessler commented that U.S. material superiority rendered traditional battlefield tactics irrelevant, while Colonel General Jodl asserted that Germany succumbed not due to battlefield losses, but to the overwhelming industrial capacity of the United States, particularly the contributions of women workers, which German planners had severely underestimated. The women who staffed these factories fundamentally transformed society. Having proven their abilities, they resisted returning to pre-war domestic confines. The productivity techniques they developed, systematic training, task simplification, and continuous improvement laid the groundwork for post-war economic growth. Individual contributions, such as Rose Willow Monroe at Willow Run, thousands at Douglas and Boeing plants, and welders at Richmond shipyards, collectively formed what Franklin D. Roosevelt famously termed the arsenal of democracy. Each worker represented countless others whose labor directly influenced the outcome of the war. Unlike the coercive methods employed by Axis powers, American women worked with motivation, pride, and fair compensation. Their systematic approach to production, breaking complex processes into manageable steps, set new global standards. The wartime experience demonstrated that high-quality results could be achieved through training and organization, not just traditional craftsmanship or gender-based assumptions. The contrast with German women who remained largely excluded from industrial roles highlighted a broader lesson. Pragmatically harnessing all human talent, irrespective of ideology or gender, proved far more effective than restricting half the population. Mass production under American methods delivered precision, reliability, and volume, multiplying combat effectiveness through superior equipment and logistics. This history underscores enduring truths about human potential. German planners could not fathom that a democratic society could outproduce a dictatorship, that women could match men in industrial capability, or that voluntary labor could outperform coerced work. By measuring American potential against their own limitations, Axis leaders misjudged the scale and speed of US output. American women shattered these assumptions, proving that when barriers are removed, extraordinary results follow. By dismissing women workers in 1940, German generals unwittingly guaranteed their own defeat. As these women went on to produce quantities exceeding the entire Axis output, ideological rigidity collided with practical reality. The ultimate arbiter of victory was the collective effort of millions of American women whose labor demonstrated that freedom and opportunity unleash power that tyranny cannot replicate. Their contributions not only secured military success but also laid the foundation for post-war societal and economic transformation, showing the long-term potential of fully mobilized human talent.